Hello, I'm Declan Kanice, and I worked with Victoria on the weather station. I was in charge of the program waiting system, work on sensors and some of the code, whereas Victoria was the group leader, worked on the program base code and the program display data. So the weather station takes in a variety of information points from an outdoor station and reports on the quality of weather. It records temperature, wind, and light level, and it will display data through a buzzer to show how it compares to optimal conditions. The hardware is two ADCs, which will be connected to the thermometer, the flex sensor, and the photoresistor. And then we will also have a button and a buzzer. To operate this, you can place the temperature monitor outside or by a window, and you can signal when to record using the remote desktop. You can keep your findings, and if you are near the computer, you can press the button to hear an auditory signal. The wiring is shown, and as you can see, is fairly simplistic, just mostly the flex sensor and thermometer and the photoresistor using the ADC. The button and buzzer system is fairly simple, and what it does is when you click the button, it will report on 1, 2, or 3 buzzes to show you how it compares to optimal weather, optimal being 3 and poor being 1.
Hello, and welcome to the code for our weather station. Here are the usual imports, and the action is down here. We first ask for the input on how long to collect the data and the intervals between the data collection. Then we set up our constants, the NumPy arrays to collect all of the data, set up the buzzer and the button. Then we enter a while true loop, and only once the button is pushed, the time starts, and it says that it starts collecting data. So while it is within its set duration, it takes in input from the thermometer, the photoresistor, and the flex sensor. And it converts those into usable data and appends them to the appropriate array, waiting the appropriate interval and repeating this until the duration has finished, when it prints collection done. After it is done in this while loop, it enters another while true loop, where it waits for a button input once again when it calls these two functions. First, it calls conditions with the 3 data arrays. That is from the method up here. It takes the 3 arrays, takes the average of them, then with those numbers, depending on what the temperature is, it assigns it a value based on whether that is a good weather, an average weather, or a bad weather. And it does the same with the light conditions and the wind conditions. It then combines all of those evaluations into a single weighted average and returns that number. Back in the call, it returns that number and gives it to the conditions sound function as well as the buzzer pin, which is the second method up here. So based on what the condition is, it takes it and has the buzzer make a sound at a certain frequency for a certain amount of time, a certain number of times, and returns what the overall evaluation is. It has that for a good, an average, and a bad weather evaluation. And then after we have that final condition stored from the condition sound and it has made the buzzer create the sound that we want, it saves all the arrays to a zip file and breaks from that loop. This right here is the display of the data. When it was last run, it was at a 3 with the weather being good. And these are some of the graphs that we had for that. Thank you.
Overall, when you submit the amount of time and the amount of intervals you need to take, the system will report back to you on the quality of weather. This could be useful in a variety of situations, such as leaving it outside all night to compare the weather overnight, or even leaving it by a window to connect to some automated system to close the window. Thanks.